Welcome to the NN Classroom. Today I'd like to share with you another specimen question, multiple choice from paper 1. So that is question number 16. It is another really standard class type of question that always pop up in the IB paper 1. That is to say, ask you to give the expression of this equation or after you work out the question in terms of expressing the equation. For this case, again, as mentioned before, the technique of handling this kind of question is that never look at the choice first, because the choice will always be so misleading. So what we try to do is to try to make up our own expression and then to look back which expression is meeting our expectation. Alright, so for this case, let's see for the question, right? From here, they're saying, when 0.46 grams of ethanol is burned under water-filled calorimeter, a very important apparatus that helps us to measure the energy change of a certain reaction, called calorimetry. The temperature of 500 grams of water is raised by 3 Kelvin in terms of the temperature, and given the molar mass of ethanol is going to be 46 grams mole, specific heat capacity of water is 4.18 joules per gram per Kelvin, and given also Q equals mc delta T, a really critical equation that helps us to convert some of the parameters now to a really critical value, that is the heat energy, right? And they're asking, what is the expression of the enthalpy change of combustion? So first of all, behind is what we are now finding, the enthalpy change of combustion. So here comes a really important idea about the definition behind this enthalpy change. As you know, in our topic 5 of IB syllabus, there's a lot of enthalpy changes that we need to know, so clear about that definition. But remember, student, whenever they are asking for any definition of enthalpy changes, always bear something in mind, that every enthalpy change must have something that need to be per mole, must have something that need to be per 1 mole. So in the case of combustion, we need to be in per mole of fuel according to the definition. That means the enthalpy change of combustion is defined as the energy released when 1 mole of the fuel is completely combusted in air. So that's why at the end we must be having an idea that we must be dividing the number of moles of the fuel. Just like in this case, the mole of the fuel should be related to the moles of ethanol that we burn away. So that's why whenever handling calorimetry situation, and when we do the equation out, always bear this in mind. 2 equations to go with. The first one is Q equals m times C times delta T, which is given. And the second one is that delta H is equals to the Q over the mole. And the mole that we plug in is always be restricted by the definition of the target delta H. So just like this case, if it's combustion, so we expect this is the moles of the fuel, right? So far so good. So when we know about that, so now we can plug in the data, right? First of all is the mass. Sometimes students may kind of having troubles in selecting the right mass, because in this case you will see that there's 2 masses that's given. The first one is the mass of the ethanol, and the second one is the mass of the water. Bear this in mind. When we want to plug in the correct number of the mass, we must be ensuring that this mass is the mass of the substance that is related to the changing of the temperature. So that means if the mass is related to the substance that is undergoing the change in temperature, that is the right mass. So just like this case, if we're really clear about the setup, who is the one that changing in temperature? It is the beaker of water. So that's why in this case, we must be plugging in 500 into this M instead of 0.46, because 0.46 is related to ethanol, and ethanol is definitely down there underneath the beaker of water, in which that is not the one that we are measuring for the temperature. In this case, the temperature rise goes to obviously the beaker of water. So that's why the mass that we plug in must be the 500 grams. So that's why in this case we should state Q equals mc delta T, and so the M this time is 500. Next thing, which is the C, always be the specific heat capacity of the substance. So in this case, obviously it's going to water, so 4.18. And finally, the delta T, for this case, which is the rise in temperature in Kelvin, so that is 3. Yeah. But one more thing to remind students is that for the change in the temperature, in this case, delta T, right? For delta T, no matter it is in Kelvin or degrees Celsius, it's going to be the same number, because in terms of the temperature difference, we are just moving the difference by 273 units between Kelvin and degrees Celsius. But the thing is, the difference is always be the same. So that's why when they're asking for delta T, no need to change the unit from degrees Celsius to Kelvin, right? So that's why in this case we will having the first expression that having the energy in joules. So that's why the second step that we do is that we need to change this joule unit into kilojoules unit. So that's why 500 times 4.18 times 3 divided by 1000. So that brings us to the unit of kilojoules. Alright, so afterwards, as mentioned before, right, the first step that we have done is the Q equals mc delta T. So what's the next step? Is that we put the Q divided by the moles, right? So I just write down there. So that's why in that case, the delta H will be equals to the Q divided by the moles. So that will be our top number, 500 times 4.18 times 3 over 1000, right? And these number over the number of moles. So in this case, as mentioned before, the moles is related to the moles of the fuel. Luckily, this case, the mole of the fuel, which is going to be 0.46, the mass of the ethanol over the molar mass, which is going to be 46, right? 46 will be the molar mass because mass over molar mass equals moles, right? And don't forget that this is going to be an exothermic reaction. So exothermic means we need a negative sign in front. So that's why all the choices that you see in the given situation are all negative numbers. That makes sense, right? So finally, we better simplify first. So that will be equals to 500 times 4.18 times 3 times 46 over 0.46 times 1000, and then it is going to be a negative number. So after we have our own expression that is simplified, right, according to the basic algebra, so at the end we can check the answers back to the choices, right? And you realize that in this case the answer goes to the best matching will be C.